All right, on page 2, I'm going to focus, or page 3 rather, I'm going to focus in on problems 4 and 5. We're going to set them up, and we probably won't finish solving them because at a certain point it's just punching it into the calculator, but we're going to set them up the way that you would need to solve them, and I'm going to explain the differences in these two. So in problem 4, the question that it's really asking is how much time has passed. So we're going to need to solve for t. In question 5, the question is asking how much nicotine was there. So when we set these two problems up, we know that in the first one, we're going to be solving for t, time. And in the second one, we're going to be solving for p, how much was there initially if right now there's 10 milligrams. So I'm going to talk about the differences in solving for those two variables. In problem 4, the steady rate is 5%, and it should have said right here per year, which we adjusted in class. So when I set this up, we're not going to be using anything about compounding interest. It doesn't say the word compounded in here at all. We're just going to use our regular old formula. A equals P times the rate to the T over N power. Remembering that our rate is going to be 1 plus or 1 minus this 5% that they give us here. But since the population is growing, that rate is going to be 1 plus 0.05. So we're going to have 1.05 as our rate. We know we're going to be solving for time. And right here it says that it's growing every year. So n is just going to be 1. Now, right now, there are 89 people in the town. But how much time has passed since there was 70 people? We know that we're dealing with growth, so initially there would be less people than there are now, and we're just solving for time. The reason I want to bring up this scenario is because it's different than how we're going to approach solving problem 5. So we're going to set up problem 5 and then talk about the differences. In problem 5, it's telling us that the half-life of nicotine is 2 hours. So if we have half-life, we already know that our rate is 0.5. Again, we don't have anything compounded. We're not dealing with any compounded interest. So 0.5 is our rate. We want to know how much there was in the system, so we don't know P. 8 hours ago, so time is 8. And don't forget that your N is 2 because they say that the half-life is 2 hours, which means that this half-life kicks in every 2 hours. So you're going to take your time and divide it by that amount to figure out how many times the half-life has actually affected the system. And lastly, we currently have 10 milligrams. So the reason I want to bring this up is because now that we've set up our two problems that are different in which variable we're solving for, the first step is different. In problem 4, the first thing you'll need to do is divide both sides by 70. And that's because you're solving for t, and this 70 is just being multiplied by this term right here, so you can get rid of it. Over here, you're also going to do that. But instead of dividing by p, you're going to divide by 0.5 to the 4th power, and that's just 8 divided by 2, which will be the first thing you do. So by doing that, you'll have p by itself. That's going to be 10 over 0.5 to the 4th. And all you have to do there is just punch that into the calculator. On this side, you have 89 70ths, and now you have 1.05 to the t power. You can't divide by 1.05 because there's only one way to get an exponent to be the only thing left on this side of the equation, and that is to use a logarithm to swing this 1.05 over to this side. So when we set this up and that 1.05 swings over to the other side, you have to introduce the log of 89 70ths, and now your time is this all by itself over there. So at this point, you could just punch that into the calculator and this into the calculator, and you'd have your answer. But I wanted to bring that to your attention because when you're solving for p, your only step really is to divide by this other stuff, get it out of there. When you're solving for t, you have to swing the base over, so you'll have to wait until the only thing you have left is this, get the base out of there, and then you'll have t by itself. So if you're solving for an exponent, you need a log. If you're solving for the principal amount, you don't. You just have to divide by your exponent, this term over here. All right? And that's it for 4 and 5. Lastly, I'm going to do a problem on the back.